Arithmetic sequence. A sequence is a list of numbers in a particular order, such as 1, 4, 7, 10, 13. Each part of that sequence is a term. 1 is a term, 4 is a term, 7 is a term. In an arithmetic sequence, each term is brought about by adding or subtracting a number from the previous term. So in this case, to get to 4, we take our first term and add 3. From 4 to get to 7, we again add 3. And our next term, when adding 3, will be 10. Let's take a look at this sequence. What number needs to be added or subtracted to the previous term to get the next term? Between the 2 and the 5, we will add 3. 5 and 8, 3, and so on. You can check it down here with 11 and 14, again, is 3. Let's take a look at this sequence. What number needs to be added or subtracted to go from one term to the next? To go from 7 down to 3, we need to subtract 4. 3 down to -1, subtract 4, and -1 to -5, also subtract 4. These numbers we use to move from one term to the other, either adding or subtracting, is called the common difference. To figure out a certain term from a sequence, we can use a formula. Starting with the first term, which we will call A or A1, and D, which we just discussed, stands for our common difference. We know that to get our second term, in this case is 5, we need to take 2 plus our common difference of 3, we get 5. So now we know that A2, our second term, equals A1 plus our common difference, and that gets us our A2. What if we wanted our third term? That is 8. We know that we took our second term, added our common difference, and we got our third. Using substitution, we can take out A2 that we have here and replace it with A1 plus D. So our third term becomes our first term plus D, which replaces our second term, plus D again. Otherwise, A1 plus 2D. We can actually consolidate this into a formula that we can use for all terms. Our formula is A, we use our subcase n, A sub n equals our first term plus however many terms we want minus 1 times the difference. Remember, to get our third number, we substituted to find it was the first term plus D, which equals A1 plus 2D. Well, here we see our third term, and the number of D's we have is our third term minus 1, which is 2. We can check this by taking our first term from our purple sequence, 2, plus 2 times the difference, which we said was 3, and that will equal 2 plus 6, which equals 8, our third term. Let's check this and find our fifth term, 14. We want our fifth term, so we'll say A sub 5 equals our first term plus our number of terms minus 1 times our difference. Our first term is 2. We want our fifth term, so we'll do 5 minus 1, and our difference is 3. That becomes 2 plus 5 minus 1 is 4 times 3. 2 plus 4 times 3 is 12, and 2 plus 12 is 14, and sure enough, that is our fifth term in our sequence. Let's take a look at this example. -1, 3, 7, and 11. First thing we must do is find the common difference. What number must we add or subtract to each term to get the next? To go from -1 to 3, we must add 4. To go from 3 to 7, again adding 4, and again check from 7 to 11, we add 4. So our common difference, D, is 4. What if I want to know the fifth term? we should expect the fifth term, adding 4, to be 15. Let's check it using our formula. Okay, we would like our fifth term, which equals our first term plus our number of terms we want, 5 minus 1 times our difference. So that equals negative 1 is our first term. We want our fifth term, so 5 minus 1 is 4, and our difference we set up here is also 4. Negative 1 plus 4 times 4, which is 16. Negative 1 plus 16 equals 15. Exactly what we expected. However, what if I want the 45th term? You certainly don't want to be adding 4 for another 40 or so terms. So let's use our formula here to find the 45th term. So again, we will start with our first term, negative 1, and we'll add the number of terms we want, 45, minus 1, multiplied by the difference. We're still dealing with the same sequence, so our difference is still 4. Negative 1 plus 45 minus 1 is 44. Multiply that by our difference of 4. We have negative 1 plus 176, and we will get 175. That was much faster using the formula than it would have been had we just added 4 40 more times. Let's look at another example. How do you find the 39th term when the first term is negative 3 and the 24th term is 89? So we want to find the 39th term, but remember, in our formula, we currently don't have our difference in this equation. So we need to use the idea of having the first term and the 24th term to find the difference. Here's how we do that. We know that the 24th term will be the first term plus 24 minus 1 times our difference. Well, the 24th term is 89. Our first term is negative 3. And since our n minus 1 is 24 minus 1, this becomes 23. And we still don't know our d. What we now have is an algebraic equation that only has one variable, d. As long as we can move this negative 3 and the 23 to the opposite side of the equal sign, we will be able to figure out our d and find our 39th term. Following order of operations, add our 3 to both sides. 91 equals 23d. Divide by 23, and we find that our d equals 4. Now that we have our d, let's find our 39th term. Our 39th term will be our first term plus our number of terms minus 1 times our d. Our 39th term becomes negative 3 plus our 39th term minus 1 times our difference, which is now 4. Negative 3 plus 38 times 4. You can also use parentheses or the multiplication sign. Negative 3 plus 152. Add those together, and we get 149, which is our 39th term.